Welcome back to another question from IBDP MAA HL paper 1. GDC is not allowed for this question. Here is the problem. It says the line L1 has the vector equation this one, and L2 line is also having this vector equation given by this lambda and mu A and lambda mu B are real numbers. L1 and L2 are perpendicular. These two lines are perpendicular. This is first information, as well as they intersect at a unique point. So how can we use these two informations to get the values of A and B? First thing, if lines are perpendicular, two lines are perpendicular, and let's say they have their direction vectors as u and v, then in that case the dot product of u and v must be equals to 0. Okay, u dot v must be 0 if two lines are perpendicular. Their dot product is 0. So here, what is the u vector? Direction vector of the first line. That is x component is 0, y component is a, and z component is 1. This is u vector. Now for the second line, this one, we have the v vector value. Let's write v is equals to this one is the direction vector. Okay, so here it is 1, 2 and 3. So this is v vector. As I said, the dot product must be 0. You can also go through your formula booklet. Here, the scalar product of two vectors v and w is given by this v1 w1 plus v2 w2 plus v3 w3 for these two vectors. Okay, so here also I will use the similar thing. I will get dot product of u and v must be equal to 0. That means multiply their x components, means 0 times 1 plus a times 2 plus 1 times 3. This quantity must be equals to 0. That gives me 2a plus 3 equal to 0, or 2a equals to negative 3. That gives a equals to negative 3 by 2. So this is the value of a. Now we got the value of a. We have to solve for the value of b also. Okay. Let's try to find the value of b using the information that these two lines intersects at a unique point. So if these two lines intersects at a unique point, it means there is a point over here that must be satisfied by equation of both the lines. Okay, so if an equation of a line is already given to us, we can convert it into parametric form and get the coordinates of any point lying on the line. For example, if we have r equals to a plus lambda b vector, this is the vector equation of the line, we can convert it into the parametric form by this x equals to x naught plus lambda l and so on. So this is parametric form which gives us coordinates of every point lying on that line for some particular value of lambda. If you choose different values of lambda, you will get different point lying on that line. Okay, so here also I will use the same concept and will get the point or general point lying on both the lines, and I will equate the points because points are same and get the value of b from there. Okay, I'll show you. So for the first line L1 line have the equation of r is equals to 4i minus k plus lambda times aj plus k cap. So using this equation, we can say our x value from the first line will be equals to 4 x component. I'm comparing the x component only. So I cap component on both the sides. So we get 4 plus 0 lambda. Okay. Then we have y value from first line only, means comparing the j cap coefficient. So that is 0 plus lambda a, that is for j. And for z component, means k cap coefficient, we have minus 1 plus lambda. Now similarly for the line L2, we have x value as, means find the x component, y component and z components from here. So we will get x component, means the coefficient of I cap, that is 1 plus mu. Then for the y component, we have 0 plus 2 mu. Then for the z component, compare the k cap. So minus b plus 3 mu. Since these 2 points lying on these 2 lines are same, right? Because they have a common point. So I can equate the x values, equate the y values and z values. Okay, so let's equate these values and get the values of b, lambda, mu from this. So on comparing their x parts, I get 4 is equals to 1 plus mu. That gives mu equals to 3. So we got the value of mu. After that, y components. That gives me lambda a. We know already what is the value of a. It is negative 3 by 2. So negative 3 by 2 times lambda is equals to twice of mu, and mu is 3. Okay, so on comparing their coordinates, we get this. So simplified for the value of lambda. Lambda comes out as 3, 3 cancelled. 2 times 2, 4, negative 4 is the value, lambda. We got the value of lambda. Now equate their k cap coefficient or z coordinates. So basically we have 1 plus lambda, means lambda is what? Negative 4. So 1 minus 1 minus 4 equals minus b plus what is mu? Mu is 3. So 9 will appear over here. So b goes to this side, change the side and take all the constant numbers to the right hand side. So we get b equal to 9 plus 1 plus 4. That gives b equals to 14. Hence, we got the value of b also. That's it. So in this way, we can simplify these questions. Okay, so for these type of questions, you are using the concept like if dot product is 0, then the lines are perpendicular. Okay, and you have to take their direction vectors only. Like r vector is equals to a1 plus lambda b1. So r vector equal to a2 plus lambda b2. This b1 and b2 mu, I'll use different letter, mu. Lambda and mu are real numbers. Okay, so from here we can say this b1 and b2 are the direction vectors, and if lines are perpendicular, then b1 and b2 must have their dot product as 0. Okay, and this a1 is any point lying on the first line, given point. A2 is any given point lying on the second line. Okay, and on comparing their I cap, J cap, and K cap coefficients, we can get the coordinates of general point lying on that line, as we did for the part this one, right? So that is it. Still, if you have any confusion or want to ask any question, feel free to connect with me, and you can also contact me on this number. Okay, to book your demo session, or you can have trial sessions or group sessions. Okay, thank you for watching this. See you in the next part. Keep watching, keep learning.